So in the diagram over here, we can see we have two lines. And if I look at those two lines, I think it looks like they're parallel. It looks like if they keep going in both directions that they're never going to intersect, which is what we think of parallel as meaning. But I want to take a few minutes to examine what is it about these lines that makes them parallel. Is there something about them, something kind of maybe quantifiable, something identifiable about them that indicates that they're parallel? And so I want to think about what would happen if I took one of these lines and I made it so that it's obviously not parallel to the other one. So you can see I just kind of dropped it down now. I still have point B kind of hanging out up there, but I dropped that line down. And so we can see that even though in the diagram that I have they're not intersecting, if they keep going off in this direction, eventually maybe someplace out in here they would intersect. So by changing the tilt of that line, by making it maybe a little bit more flat, it was going up here like this, a little more slanted upwards, and I tilted that line down a little bit, and that made it so that it's no longer going to be parallel to the other one. So if we think about that, if two lines are parallel, we can think about the fact that they're going to be slanted in the same way, right? If I move this guy back up here, now we can see like the tilt of this line is matching the tilt of that line. When I changed its tilt, when I made it more flat, it was no longer matching the tilt of this one, it was no longer parallel. And so that idea that the tilt or the slant of the lines and the fact that that tilt and slant matches makes them parallel, that indicates that what we're talking about is the slope of those two lines. Because if you remember, the slope of a line is like a number that describes how tilted or slanted the line is. So the fact that these are maybe parallel indicates that they have the same slope, perhaps. Well, let's investigate. Let's see if we can look at what the slope of these lines would be. So first of all, we need to remember a few things. We need to remember that slope is often indicated by the lowercase letter m. So m is the slope, and the way we figure out the slope, there's a few ways we can describe it. A lot of people think about slope as being rise over run, right? If I go from one point to another, how much did I go up or down versus how much I went right or left, right? Rise over run. Another way to think of slope is how much does the y coordinates change as I go from one point to the next. So we would call that delta y. Delta means change in. So what's the change in the y coordinates compared to delta x, the change in the x coordinates? And this matches. These two things match because when we move up or down, we are changing the y coordinate of our point. And when we move right or left, we're changing the x coordinate of our point. So by saying delta y and delta x, we're really still describing rise over run. And then I said that delta, it looks like a triangle, but it's the Greek letter delta. That represents the change in. So how do we find the change in y or the change in x? Well, we take one of our y coordinates and we subtract the other one. And to find the change in x, we're going to take one of our x coordinates and subtract the other one. So let's do that. Let's take a look at this line here, line AB, and let's find the slope of line AB. And the way I'm going to sometimes denote this is I'm going to say m of line AB. And that m now means slope, not measure. I know it's confusing that we use a little lowercase m sometimes to mean measure, but now we're talking about the slope. So, okay, let's identify the 2 points in A, or the 2 coordinates for A and B. So A, it looks like, is at negative 1, 2, 3, 4, positive 2. I had to go from the origin, I had to go backwards 4 and up 2 to get to A. So that means its coordinate is 4, 2. To get to B, it looks like from the origin, I'm going to go 1, 2, 3, 4, 5 units over, and 1, 2, 3, 4, 5, 6, 7, 8 units up. So that would make the coordinate for B 5, 8. So if I'm going to find the slope of line AB, I'm going to take the 2 y coordinates and subtract them. So that would be 8 minus 2. And then in the denominator, I'm going to take the 2 x coordinates and subtract them. Now what I have to be careful of, since the order of subtraction matters here, I need to be consistent with which x and y coordinates I put at the beginning. I chose to put the 8 at the beginning of my y2 minus y1. Oh, I just realized I have y2 minus y2 over there. Let me just fix that real quick. Okay, so that should be y2 minus y1 right there. So I chose, when I was calculating the change in my y's, I chose to make it this y minus this y. Now, in the bottom, when I choose, or when I find the difference in the x's, I need to do that same order. So I am going to do 5 minus negative 4. And now I'm just going to simplify this. 8 minus 2 is 6. 5 minus negative 4 is going to be the same as 5 plus positive 4, because when I subtract, I'm adding the opposites. So that's going to be a 9. And then when I reduce that, I can divide both the top and the bottom of that fraction by 3. So that's going to give me 2 over 3. So the slope of this line up here is going to be 2 over 3. Every time I go 2 units up, right? So if I go 2 units up, I go 3 units over, and I'm still on the line. 2 units up, 3 units over, 2 units up, 3 units over. Every time I do that movement from one point, I'm going to get back to the line. It has a slope of 2 over 3. And if we think about that for a second, it's a positive slope, which makes sense because, as we learned, lines with positive slope, they go upwards as we move from left to right. So the slope of line AB was 2 over 3. Now let's just kind of verify that line DC has the same slope. So now we're going to do the slope of line CD or DC. And so let's think about the coordinates of points C and D. Now if I look at point C, I had to go from the origin backwards 1, 2, 3, 4, and then down 1, 2, 3, 4. So that coordinate would be negative 4, negative 4. And then to get to D from the origin, I go over 1, 2, 3, 4, 5, and up 2. So the coordinate of point D would be 5, 2. So now to find our slope, we're going to take the y minus the y, so that's going to be 2 minus negative 4. So 2 minus negative 4. And then the denominator is going to be 5 minus negative 4. 5 minus negative 4 for my denominator. Okay, 2 minus negative 4 is going to be the same as 2 plus 4, and 5 minus negative 4 is going to be the same as 5 plus 4. So here we have a slope of 6 over 9, and we already reduced that. We know that comes out to be 2 over 3. So the slope of line CD is 2 over 3. And so what we can see now is our two lines have the same slope. On each line, if I go up 2 and over 3, I get to another point on my line. It has a slope of 2 over 3. And they're parallel. So what that tells us is that for parallel lines, they will always have the same slope. They will always have the same slope. So let's see what we can do with that. Let's look at a quick example. We want to look at this diagram, and we want to see, is line K parallel to line N? So here is line K, it's this line right here, and here is line N. If I just eyeball it, kind of looks like they're parallel. It kind of looks like if they keep going in both directions, they're never going to intersect. But let's just verify. Let's see, are they truly parallel? So the first thing I want to do on line K and line N is I want to pick out 2 points on those lines that are easily identifiable in terms of their coordinates. Like right here I see a point where that line goes through one of the kind of intersections of the grid lines on the graph. So I'm going to identify that point there. And then I'm going to try and find another point that it goes through the grid lines. If I keep tracing down, it looks like there's a point right there. So I'm going to name that point. Okay, so let's call that point A, and let's call this one point B. And let's find the rise over run if I move from A to B. Now I notice that I'm going down, so I'm expecting a slope that's going to be negative. And so if I go down 1, 2, 3, 4, 5, and then over 1, 2, 3, 4, so that movement was to get from A to B was to go 1, 2, 3, 4, 5 down and 1, 2, 3, 4 over. So we're going down 5, but over 4. So that tells me that my slope of line K, let's say m of K, or slope of K, is equal to down 5 over 4, negative 5/4. So now let's investigate the slope of line N. Again, I need to find a couple points where my line crosses through an easily identifiable place where the coordinates are easily identifiable. So that would be this point right here. And if I keep tracing down, it happens again right there. So I'm going to label those points as, let's say, C and D. So we'll put point C there and point D there. Now to get from point C to point D, I can go down 1, 2, 3, 4, and over 1, 2, 3. So the slope, it looks like the slope of line N is equal to negative 4 over 3. And now I see, hey, look, these slopes are not actually the same. They're pretty close, right? Negative 5/4, negative 4/3. Those are actually two numbers that are fairly close. This is like negative 1.25. This is like negative 1.3 repeating. So they're pretty close, but they're not equal. So what I can say is that no, line K is not parallel to line N because, that's my little abbreviation for because slopes are not equal. Okay, so that tells me that line K and line N are not parallel. So now let's check out M and Q. Here's M, line M. Here's line Q. Again, eyeballing them. They look like they might be parallel. But let's find a couple points on line M. Looks like here's a point on line M and here's another one. And then let's do the same thing for Q. I'm seeing this point right here, and then I'm seeing this point right here. So now let's think about the slope. This slope, if I move from this point to this point, I'm moving upwards as I go kind of to the right along my line. So I'm expecting these to both have positive slopes. Line M's slope, I go up 1 and right 3. So it has a rise over run. So the slope of M is equal to up 1 and to the right 3. So a slope of 1/3. If I look at line Q, to get from here to here, I'm going up 1, 2, and then over 1, 2, 3, 4, 5. So rise of 2, a run of 5. So the slope of line Q is equal to 2 over 5. Again, I see these two slopes are not equal. So I have to say, no, line M is not parallel to line Q because the slopes are not equal.